Welcome to the lecture on definition 3, circular functions. The first one here we already encountered in the previous section. The arc length in a unit circle is the angle in radians. And here is the third definition. By the way, the footnote here that you don't see right now, but it's in your notes, means that the image is from flickr.com, which means it's a public image. So here's the unit circle, really similar to the one that you have in your book, and it shows the degrees in radians, the angles in radians as well in degrees. So pi over 6 is 30 degrees, pi over 3 is 60 degrees, 5 pi over 6 is 150 degrees, and so on. And in the unit circle, the radius is 1. And so here we nicely have then defined the y coordinate and the x coordinate, which for example for 30 degrees comes out to square root of 3 over 2 and 1 over 2, as I said, with a radius of 1, and you can easily check that with the Pythagorean as you square root of 3 over 2 plus 1 over 2 squared, and that comes out to 1 all the way around here. The cosine therefore is defined as the cosine t, this arc here, is defined as simply the x-coordinate, and I will just call it the adjacent. The sine t would be defined, so the sine here, the radians, the arc length, would be defined as the y-coordinate, in this case 1/2, or as I call it, the opposite. I pretty much just use, with all these three different definitions, I just like to adhere to the one definition that talks about the opposite and the adjacent to the angle. And of course you don't see the r equals 1 here simply because r is 1, so we don't need to write it down. Tangent, as usual, opposite over adjacent, and then the inverse, the reciprocal functions. Not the inverse, the reciprocal functions, that's correct. Graphing the unit circle with parametric equations. Should say something about the unit circle here. Make sure that you memorize them at least in the first quadrant, and that of course you're familiar with that. The cosine is positive in these two quadrants and negative in these here, and the sine is positive in these two and negative in these, and the tangent of course is positive here and here, negative here and here. That derives from applying the positive or negative y and x to the tangent respectively. Tangent is the same as sine over cosine. Graphing the unit circle with parametric equations in the graphing calculator. I'm going to show that. So we're going to go over to the graphing calculator. No, we're not going to go over there. We're going to go over here, graphing calculator. There we go. What we're going to do is we click on mode. And the fourth one down here says that usually we're in function mode where we have y equals. This time around we want to be in parametric mode where we have x equals something in t and y equals something in t. And I'll show you in just a moment. And I guess we're supposed to function in radians here rather than degrees, so I switch that as well. Okay, let's get out of it. And here y equals, which looks different now. We have x equals something and y equals something. For the unit circle, we would need an amplitude of 1 times cosine of the angle. And of course I can leave this out. I don't have to write this. I'm just going to say, well, cosine of the angle, and it goes automatically that t that you saw there, cosine t, sine t. I'm going to go to Windows to see that I have good values here to graph, and in fact my t goes from 0 to 2 pi. That's good in radians. Here the t step, I may want to make sure that that one is in pi over 12, so that we have in increments of 15 degrees. And then the x and the y, we'll see how that graphs. So let's graph. There's the unit circle. We could perhaps, for one thing, we should check that really the x's are adjusted. Usually it's z standard. And you notice that, ooh, this doesn't look like a circle. Let me zoom in actually. Oops, sorry, zoom in. Zoom in, zoom in. Usually, these are the way the x's are. They're distorted, but you can see that this one here is 1 on the x-axis, 1 on the y-axis. That's why the calculator is doing that. But that really doesn't help us. So what we do instead is, let's see, I believe I go to, yep, zoom, and then down to z square, and that adjusts the axis. Okay, what I said a moment ago, now they're correct. This is 1 and this is 1 here. And now we get a nice circle, except the resolution on the calculator isn't really that great. I'm going to change the window setting a little bit here on the x minimum, so maybe I make it a negative 1.5 and a positive 1.5. It just will make the circle a little bit bigger. Of course, we're back to an ellipse, so we do z square. There we go. And if I zoom in now, I believe I get it off the screen. Sure enough. All right. Let me do this one more time. -2 and 2. And z standard. No, z square. There we go. That looks a little bit nicer. When we trace here, the up and down arrows are not going to do anything for us. They're used for, in graphing mode, they're used to switch from one equation set to another. They only have one equation set. So we're going to use the left and right buttons. With the right button, we increase the value of t, and of course we're going counterclockwise, as we do in a circle. With the left button, of course, we would go back. We cannot go any further back than 0. Notice that. Can't go any further back because in the window we defined that the smallest t value that we have is 0 and the largest one is 2 pi. So I can't go any further than 2 pi either, because I'm going to get rid of this one here, because the largest t value defined is 2 pi. And then we can look at here, for example, here we have t equals 2.61. What would that correspond to? Well, that's 5/6 of pi, and when you plug it on the calculator, 5/6 times pi, you indeed come up with 2.61. 5/6 pi, it's also the same as 150 degrees, and then we come up with the x of negative, the x being negative 0.866, and that would be the value for the cosine as well, because it just goes with the x value. So cosine of 150 degrees, of course, is negative square root of 3/2. The y value here is 0.5, and we're all familiar with that. Sine of 150 degrees is 0.5. We just have to memorize. Anyway, this is the unit circle on the graphing calculator with parametric equations. Just in case, usually I'm in function mode, I may want to go back to this one here and switch this to function mode so that the next time around I'm not getting confused if I don't need parametric equations. Do I want to switch back to degrees? That depends on what the next problem will bring. In trigonometry, it turns out that you have to switch forth and back quite often, depending on if the problem says degrees or radians. So I'm just going to leave it in degrees for now. I'm sorry, in radians for now. All right, let's see if we have anything else left. Should. Even and odd functions. Cosine is an even function because cosine of the negative angle equals cosine of the angle itself. Let's do an example. Cosine of negative 30 degrees, for example. Is that the same as cosine of 30 degrees? Well, cosine 30 degrees, which of course is a reference angle to that, is 0.866. We know that. So cosine of negative 30 degrees, well, a reference angle to that, of course, is 30 degrees, so 0.866 respectively. The negative 30 degrees is the same as 330 degrees, to which the reference angle is 30 degrees. And then we're in the fourth quadrant with this one here, which means the state is positive. And yeah, that indeed is correct. Sine theta is an odd function. So if we write sine of, let's say, negative 45 degrees, that should be the same as negative sine of 45 degrees. This one here, we know that is a 0.707 with the negative in front of it. And this one here will put us at 315 degrees, which again is a reference angle of 45, so 0.707. And we're in the fourth quadrant, so we need a negative in front of that. And of course, this result here is the same as this one here, so this statement here is true. And with that, I'm concluding the lecture on the definition 3 of circular functions.